Hello everyone, welcome to today's lesson. We will explore the application of common measuring tools together. In industrial production, measurement technology serves as a means for quality management, providing a technical guarantee for enforcing quality standards. To determine whether a part meets the required standards, measurements or inspections must be conducted. For commonly used measuring tools, it is essential not only to understand their structure and reading principles, but also to acquire the skill to accurately measure the size of products. Vernier calipers, squares, dial gauges, feeler gauges, and micrometers are typical tools for size and precision measurement. Next, we will learn through the following content. Through this lesson, I hope everyone will be able to identify and describe the structure and working principles of dial gauges, feeler gauges, and squares. Correctly use dial gauges, feeler gauges, and squares to perform size and precision measurements, and accurately read the measurement results. Let's learn about the first part, dial gauge. A dial gauge typically consists of a measuring head, measuring rod, shock-absorbing spring, rack, gears, hairspring, circular dial, and pointer. It is used to measure shape errors, position errors, and displacement of workpieces. It can also measure the length of workpieces using comparative methods. The working principle mainly involves the transmission effect of gears and levers, which converts the linear displacement of the measuring rod, caused by changes in the measured object's size, into angular changes on the dial gauge's graduated dial. The corresponding values can then be read based on the dial. The large pointer of the dial gauge moves 1 notch for every 0.01 millimeters, while the small pointer moves 1 notch for every 1 millimeter. When reading, first note the scale passed by the small pointer, whole millimeters. Then note the scale passed by the large pointer, decimal portion, and multiply it by 0.01. Add the two readings together to obtain the measured value. Let's take an example of reading the dial gauge. Step 1. Read the small scale value. In the diagram, the small pointer has not yet reached 2, so the small scale value is 1 millimeter. Step 2. Read the large scale value, which is 97. Multiply it by 0.01, yielding 0.97 millimeters. Finally, add the two values together. 1 millimeter plus 0.97 millimeters equals 1.97 millimeters. Next, let's learn about feeler gauge. A feeler gauge, also known as a thickness gauge, is a measuring tool primarily used to measure gaps or clearances. The feeler gauge is made of thin steel sheets and consists of a set of sheets of varying thicknesses, each marked with its thickness in millimeters. Before use, the feeler gauge and the workpiece must be cleaned of dirt and dust. During use, one or more sheets can be inserted into the gap until slight resistance is felt. When measuring, the movements should be gentle, avoiding forceful insertion or measurement of parts at high temperatures. Let's study the method of using feeler gauge. Before using the feeler gauge, clean both the gauge and the workpiece of any dirt and dust. During measurement, first insert the thinnest gauge sheet into the gap being measured. If there is still clearance, select thicker sheets and insert them one by one until the fit is just right, not too loose or tight. The thickness of the last sheet corresponds to the size of the gap. if the required thickness is unavailable. Several gauge sheets can be stacked and used together. The size of the gap is the sum of the thicknesses of the stacked sheets. Though this method may result in larger errors. When selecting gauge sheets, minimize the number of sheets used to account for the clearance in the mating surfaces. Since feeler gauges are very thin and prone to breaking, avoid applying excessive force during measurement to prevent bending or breaking. Restrictions on using feeler gauges. The measuring surface of the feeler gauge should not have rust, scratches, folds, or other obvious defects. It cannot be used to measure workpieces at high temperatures. After every use, apply anti-rust oil to the surface of the feeler gauge and store it in its protective casing. Then, let's learn about another common measuring tool, square. A square is a professional measuring tool, also referred to as an angle square or edge square in certain settings. It is used to inspect the perpendicularity of workpieces or the perpendicularity of relative positions between workpieces. It is also sometimes used for scribing. Squares are suitable for inspecting the perpendicularity of machine tools, mechanical equipment, and components, as well as for installation, positioning, and scribing during processing. Squares are essential tools in the mechanical industry, characterized by high precision, good stability, and easy maintenance. Before using a square, inspect its working surfaces and edges for damage. Wipe clean the working surfaces of both the square and the workpiece being inspected. When using, place the working surface of the square against the working surface of the workpiece, and use the light gap method to determine whether the angle of the workpiece is correct. Handle the square gently, placing it lightly, and avoid bending or deforming it. The above is all the content of this lesson. Through this lesson, we have learned the structure and working principles of dial gauges, feeler gauges, and squares. We have mastered the correct usage of these tools for size and precision measurements, and accurately reading measurement results. Measurement is a critical step in industrial production for ensuring product quality and adherence to standards. I hope everyone can proficiently master these skills in future studies and work, contributing to improved product quality. Please analyze the reading of the dial gauge in the diagram provided.